Today we're going to extend on the stuff that we went over yesterday with factoring quadratics. Today we're actually going to solve those quadratics. When we solve them, we have to make sure that we get all of our factors on one side of the equal sign so that it's set equal to 0. Then we're going to factor it, just like we did in the first part of this, what we did yesterday. We have to factor each quadratic. Once we get from there, we actually set those factors equal to 0 and then solve each one. This is also called finding the roots. So for example, x squared minus x equals 42. Everything's not on one side of the equation, so I have to subtract 42 first. So I'm going to subtract 42 from both sides of the equation. So I'd have x squared minus x minus 42 equal to 0. From here I have to factor it. So I write my two sets of parentheses for my factors. Split x squared up to x and x. Now what two numbers multiply to negative 42 and add up to negative 1? So, numbers that multiply to 42, 21 and 2, 1 and 42, 7 and 6. Well, one of these has to be a negative. Well, it has to add up to a negative 1, so my largest number is going to be negative. So negative 21, negative 42, negative 7. Negative 21 plus 2 is negative 19, so that doesn't work. 1 minus 42 is negative 41. That doesn't work. Negative 7 plus 6 is negative 1. Hey, there we go. So now I can put those terms in there. Now, pretty much this is what we did yesterday with factoring quadratics. Now we need to solve them. So I'm going to take x minus 7 and set it equal to 0 along with x plus 6. Set that equal to 0 and solve each one. So I have to add 7 to both sides for this one to get x equals 7. Then I subtract 6 from both sides and get x equals negative 6. There's my two answers, my two roots that x could equal, and when we plug it into that equation and make both sides true. So this one, x squared minus 5x plus 36. We always want to have that x squared term be positive. So since it's positive right now, I'm going to leave it. So I'm going to have to subtract 5x and subtract 36 from both sides. So I get x squared minus 5x minus 36 equals 0. Set up my two factors, my two sets of parentheses. So now two numbers that multiply to negative 36 and add to 0. Well, numbers that multiply to 36 are 6 and 6. They have to add up to be a negative number, so my largest number will be negative. Well, here these are the same. Those add up to 0, so that doesn't work. 9 and 4. So think about negative 9 plus 4 is negative 5. There we go. So I have x minus 9, x plus 4. Solve each one. So x minus 9 equals 0, because I want to find what x can equel. So for this one, I get x equals negative 4. And this one, I add 9 to both sides, and I get x equals 9. These are also, you can think about it, these are an intercept form for a quadratic. So if we take the opposites of those numbers, that will give us our number, our x-intercept, okay, which is also our roots. Another way we describe solving quadratics, and that is written, is finding the zeros. Finding the zeros of a quadratic is the same thing as finding the x-intercepts. So think about when we were graphing quadratics. Right now this is in standard form. Okay. If we want to factor it, we'll put it in intercept form. So if I factor it, x and x, two numbers that multiply to negative 3 and add to negative 2, well, the only numbers that multiply to 3 are 1 and 3, The 3 is going to be negative. So there's my two factors. Now what are my x-intercepts? Remember, we would solve these and find our x-intercepts. So remember, it's the opposite. So negative 1 and positive 3. So to graph that, I'd go to negative 1 on my x-axis and positive 3 on my x-axis. These are my x-intercepts. Now, why are they called zeros? Well, let's write the coordinates of this point, of each point. So negative 1. So let's find the coordinates of each point. So this one, our x is negative 1, our y is 0. Our x for this is 3, our y is 0. All x-intercepts have a y coordinate of 0. That's why these are called zeros. We want to find where it crosses the x-axis, which is known as where our y's will be 0. To solve these, though, you're doing the exact same thing. Okay, they're called zero. I went over this. They're called zeros because those are our ordered pairs, our coordinates for those points. So to solve these, we do the exact same thing that we did as before. We're still going to factor these. So x and x. Two numbers that multiply to negative 14 and add to 5. Well, 1 and 14. 7 and 2. Look at those numbers. Which numbers will give you a combination to add up to positive 5? So remember, one's going to be negative, one's going to be positive. So let's try 7 and negative 2. 7 minus 2 is 5. There we go. Now we just need to solve them. So you can set them equal to 0, or when we think about when we were graphing in intercept form, think the opposites of these numbers. Negative 7 and positive 2. Those are our x-intercepts. Those are our zeros. Because our ordered pairs for these would be negative 7, 0, and 2, 0. This is where the quadratic would cross the x-axis. Find the zeros of this. X squared minus 4x plus 4. I'm still going to factor it. So x and x. Now what two numbers will multiply to 4 and add to negative 4? Well, you can think 1 and 4. Can you change these up so that they would add up to negative 4? No. What about 2 and 2? Well, they both have to be negative to multiply to a positive and add to a negative. So our zeros here would be x equals 2 and 2. Really, it's just one of them. So they would cross right here. Our ordered pair for that would be 2, 0. This will be the last one we'll go over. So find the zeros. So I factor it. So x and x. Now what two numbers will multiply to negative 30 but then add up to negative 7? So think numbers that multiply to 30. 1 and 30. Can you make one of those negative and so it would add up to negative 7? No. 5 and 6. Can you make one of these negative? So 5 minus 6 is negative 1. We need negative 7. Nope. Make that negative. 6 minus 5 is 1. We need negative 7. No. 10 and 3. How can you configure this up so that when you multiply one of them, you multiply both of them, you'll get a negative, and then when you add them, you get a negative 7. Try negative 10 plus 3. Negative 10 plus 3 is negative 7. There we go. Now to find our x-intercepts, we can think the opposites of these, or we can actually solve them by doing x minus 10 equals 0 and adding 10. Or we can do x plus 3 equals 0 by subtracting 3. Or, just think the opposites. Opposite of negative 10 is positive 10. Opposite of 3 is negative 3. These would be our x-intercepts, also known as our zeros of our equation. So what is the difference between roots and zeros? Really, you're finding the exact same thing. You're finding your x's, but roots are the solutions to a regular quadratic equation. Your equation would have something set equal to 0. There is no y equals. Zeros are the x-intercepts, so you'll have the y equals or f of x equals. But really, they're the exact same things and finding the exact same answers. Okay? Well, have a good night. That's all for today, so we'll see you tomorrow.